Hi, now we are going to discuss joining in manufacturing. It is one of the topic. Joining, it is also called welding. You will get 2 marks question from this definitely. Two to 3 marks in gate from this subject. In welding, we discuss about majorly types of welding and design considerations and physics of welding. So first of all, welding. What is welding or joining? Welding is a form of joining of two metal pieces. Joining two metal pieces by heat, with the help of heat or without heat, or with the help of pressure. It's different ways of joining. So joining of two metal pieces with heat or without heat or with pressure or without pressure. So there are majorly divided into fusion welding, non-fusion welding. Welding is divided into two types majorly. So it is divided into fusion welding, non-fusion welding. What is fusion welding? In fusion welding, parent metals will melt. In non-fusion welding, parent metals won't melt. What are parent metals? Parent metals are the metal pieces which we are going to join. So again, fusion welding is again divided into two types. This is majorly division, like gas welding, arc welding. It's three types. Sorry. Gas welding, arc welding, and thermite welding. Similarly, non-fusion welding is again divided into two types, with heat or without heat. So we discuss one by one. So first is fusion welding definition. Fusion welding. Melting of parent metals takes place. So what is parent metal? Suppose I am joining piece A and piece B. A and B are called parent metals. this is filler material to fill that one. Here A and B are parent metals. So next, gas welding. In gas welding there are gas welding we'll send the gas in through the hose pipes and electric arc will generate, the flame will generate, and because of heat the molten metal will burn, the parent metal will burn and joint will form. So in gas welding there are four types majorly. One is oxyacetylene welding. So oxyacetylene welding, here oxygen and acetylene combine to form heat, to produce heat and water. So chemical reaction takes place. Oxygen, acetylene forms H2O, here only one H2O is there, plus CO2, 2CO2. So to balance this equation you need 2.5 molecules of oxygen. 2.5 molecules of oxygen will balance the equation. That means for burning 1 unit of acetylene we need, for complete combustion of 1 unit of acetylene means C2H2, require 2.5 units of oxygen. So for complete combustion of 1 unit of acetylene it require 2.5 units of oxygen. So for that, in oxyacetylene welding what it happens is 1 volume of acetylene so require 2.5 volumes of oxygen. So what this is again divided in oxyacetylene welding, depending upon the amount of oxygen sent it will be divided into 3 types. So out of 2.5 units of oxygen, 1.5 units sent, 1.5 units. So out of 2 units of oxygen 1.5 units is collected. 1.5 units of oxygen is collected of oxygen is collected So out of 2.5 units, 1.5 units is taken from atmosphere, remaining 1 unit is taken from cylinders. So in oxyacetylene welding there will be 2 cylinders connected to pipe. So one is oxygen cylinder and acetylene cylinder. So oxyacetylene, 1 unit from both will be sent and combined. So out of 2.5 units, 1 unit of oxygen is sent from cylinder, oxygen cylinder, and 1.5 units of oxygen sent from atmosphere. So atmosphere, it is always 1.5 units. Depending upon the amount of oxygen sent from the cylinder, you can vary 1 unit, less than 1 unit and greater than 1 unit. Then you can change the flame temperatures, all those. So depending upon the amount of oxygen coming from oxygen cylinder, there are 2 types of flames. Depending upon the amount of oxygen coming from cylinder, oxygen cylinder, there are three types of flames. First one, oxidizing neutral flame. First one is neutral flame. So neutral flame, you will get in neutral flame amount of oxygen coming from cylinder, oxygen cylinder, is 1 unit. The ratio of oxygen coming from oxygen cylinder to the acetylene cylinder, acetylene coming from acetylene cylinder, is 1:1. Oxygen to acetylene ratio is 1, which represents for every 1 unit of oxygen, oxygen coming from oxygen cylinder there has to be 1 unit of acetylene coming from acetylene cylinder. So both ratio is same. Then it is called neutral flame. In the case of neutral flame, the temperature developed, so the it is a torch end, and here this is inner cone, this is outer cone. So length of the inner is n, which explains here it is T max, maximum temperature, which is 3260 degrees centigrade. So 3260 degrees centigrade. So why it is inner cone is there? So the inner cone tells us we are sending 1 unit of oxygen from cylinder. So to get remaining 1.5 unit from atmosphere, it has to travel n distance. To get 1.5 units of oxygen from atmosphere, the acetylene has to travel a distance n. So the acetylene flame has to travel n distance to complete combustion, for complete combustion. So if it gets 1.5 units from atmosphere, it already got 1 unit from the cylinder, so complete combustion takes place. Application, neutral flame application. Here application is welding ferrous metals. For welding ferrous metals. This is used for welding ferrous metals. Next, another one is, suppose instead of sending 1 unit of oxygen, if you send more than 1 unit of oxygen from cylinder, it is called oxidizing flame. So oxidizing flame, instead of 1 unit, if you send more than 1 unit, that means oxygen by acetylene ratio is more than 1, which means more than 1 unit of oxygen is coming from oxygen cylinder for every 1 unit of acetylene. So for complete combustion of acetylene, for complete combustion of acetylene, the flame has to travel a distance less than n. Less than n, because we are sending already more acetylene from cylinder, more than 1 unit. Suppose for example, if you are sending 1.5 unit, so we need only 1 unit from atmosphere for complete combustion, as we know that we need 2.5 units of oxygen for every 1 unit of acetylene for complete combustion. So to get, we need less oxygen from atmosphere, the flame will travel less distance. So the diagram will look like the inner cone will be smaller. N by 2 to N by 3. It's not fixed, but it is N by less than that. Maximum temperature Tmax in oxidizing flame 3380 degrees centigrade. So application: oxidizing flame is used for welding brass bronze materials. For welding brass bronze equipments. It is not used for highly reactive materials because oxygen will react. Higher amount of oxygen we are sending, so there is a chance of reaction with oxygen. Next is reducing flame. So this reducing flame will form if you send less oxygen from cylinder than 1 unit. So the flame has to travel more than n distance to get more oxygen. Oxygen coming from oxygen cylinder is less than 1 unit. So for every 1 unit of acetylene we are sending less than 1 unit of oxygen from oxygen cylinder. So oxygen by acetylene is less than 1. So oxygen by acetylene ratio coming from cylinder is less than 1. As we know that we need 2.5 units of oxygen for 1 unit of acetylene to get complete combustion. We are sending less than 1 unit of oxygen from oxygen cylinder, so we need more amount of oxygen from atmosphere to get complete combustion. Of acetylene, it require more amount of oxygen from atmosphere. So to get more amount of oxygen from atmosphere, the flame has to travel more than n distance. So it may be 2n, 3n. Let's take 2n. T max equal to 3040 degrees centigrade. degrees centigrade maximum temperature. So application: For welding non-ferrous metals. For welding non-ferrous metals. This is about oxyacetylene welding. So it is very important for GATE. They ask 2 times in this. One question is on application of oxidizing a neutral flame and reducing flame. Another question is the maximum temperature developed in oxidizing and reducing a neutral flame. Another question is sometimes they asked is amount of oxygen required for complete combustion of 1 unit of acetylene. So we know that 2.5 units. So how much amount of oxygen is coming from atmosphere? That is the question. Next one is oxyhydrogen welding. Oxygen hydrogen react to form water. It is used for welding low melting point metals like aluminium. It is also used as heat source for brazing. So oxygen plus hydrogen combine to form H2O plus heat. Oxyhydrogen welding is used to join low melting point metals like aluminium. It also used as heat source for brazing. Braze welding. Next one is air acetylene welding. So we have seen oxyacetylene welding where we send 1 unit of oxygen from cylinder, remaining 1.5 units are coming from atmosphere. But here air acetylene welding, entire 2.5 units of oxygen is coming from atmosphere. Entire 2.5 units of oxygen is coming from atmosphere. So there is no oxygen we are sending from cylinder. So application. It is used as a heat source for soldering. Next one is atomic hydrogen welding. Atomic hydrogen welding is one of the another important gas welding. There are questions in this because it is special case. of gas welding, atomic hydrogen welding. So atomic hydrogen welding, atomic name itself says that it is hydrogen. Instead of hydrogen molecule, it is hydrogen atom. So it is